हां, काल मग नंतर आपण रिपल फॅक्टर इथे येऊन थांबलो होतो की फुल वेव रेक्टिफायर डायोड होता है, वो ऐसा आउटपुट देता है कि बोथ द हाफ साइकिल्स आर रेक्टिफाइड, दोनों हाफ साइकिल तो रेक्टिफाई होते हैं, लेकिन दोनों हाफ साइकिल के जगह पे इस तरह के पल्सेस आते हैं. सो दिस इज नॉट अ प्योर डीसी, दिस इज अ पल्सेटिंग डीसी. So to remove the AC factor from that pulsating DC, we use a filter circuit. हम एक filter circuit use करते हैं. Output of a rectifier consists of small fraction of AC component along with DC, and that AC component in the DC is called ripple. Ripple म्हणजे लाटा. Ripple is undesirable and is responsible for fluctuations in rectifier output. So effectiveness of the rectifier depends on magnitude of ripple components. Smaller the magnitude, more effective is the rectifier. Ratio of the RMS value of AC component to the value of DC component is known as ripple factor. So ripple factor is RMS value of AC component divided by the value of DC component. Output of rectifier is in the form of pulses. Output is unidirectional, but output does not have a steady value. It keeps fluctuating due to the ripple component. A filter circuit is used to remove the ripple. So after the rectifier we use a filter circuit. And a filter circuit consists of a simple capacitor in parallel with the load. तो इस कैपेसिटर से क्या होता है, कैपेसिटर से रिपल फैक्टर कैसे रिमूव होता है? लेट अस सी दिस. सो राइट द हेडिंग. क्या हेडिंग लिखेंगे? फिल्टर सर्किट. And we will draw the block diagram and the waveform for that. The heading is filter circuit. क्यों इसको फिल्टर सर्किट बोला गया है? क्योंकि वो एसी को फिल्टर आउट करता है, एसी कंपोनेंट निकाल देता है उसका और डीसी को रखता है उसके अंदर. सो दैट्स व्हाई इट इज कॉल्ड अ फिल्टर सर्किट. सो हाउ इज दैट फिल्टर सर्किट? वी रिप्रेजेंट द रेक्टिफायर सर्किट बाय अ ब्लॉक. दिस इज आवर रेक्टिफायर सर्किट. Then input to the rectifier is alternating current. So AC input is given to the rectifier, and output of the rectifier we represented by a point X and Y. So this is output of the rectifier, and this output is given to a filter circuit which consists of a single capacitor. फिल्टर सर्किट में there is one capacitor connected in parallel to the load. This is the output. ये load है output, and this is a capacitor of capacity C is connected. So how does capacitor filters this ripple? So as shown in figure 16.6b, that is the figure that I have drawn here. You can also draw this diagram in your notebook. Pulsating DC voltage of a rectifier output is applied across a capacitor. As the voltage across capacitor rises, तो इसको जो हमने इनपुट दिया है दिस विल बी इन द फॉर्म ऑफ रिपल्स लाइक दिस, इजंट इट? इस तरह से होगा. तो ड्यूरिंग द इंक्रीज यहां तक the capacitor will be charged. As the voltage across capacitor rises, capacitor gets charged to a point, and that point can be represented as point A. And supplies current to the load resistance. At the end of the quarter cycle, capacitor gets charged to the peak value. तो यहां पे कैपेसिटर अपनी मैक्सिमम वैल्यू पे चार्ज होता है. सो दैट वैल्यू इज Vp, पीक वैल्यू. तो द कैपेसिटर इज चार्ज टू द हाईएस्ट वैल्यू, दैट इज पीक वैल्यू. एंड देन rectifier voltage begins to decrease so that capacitor start discharging through the load resistance and voltage across it begins to drop. तो जब ये अगला हाफ साइकिल आता है, ये यहाँ पे वोल्टेज डिक्रीज होता है. सो व्हेन द वोल्टेज इज डिक्रीजिंग, दिस कैपेसिटर गेट्स डिस्चार्ज थ्रू दिस लोड रेजिस्टेंस. Voltage across the load decreases only slightly up to the point B because next voltage peak recharges the capacitor immediately. तो ये कैपेसिटर क्या करता है, उसमें डिले डालता है और यहाँ तक वो सिर्फ डिस्चार्ज होता है और फिर से ये वोल्टेज इंक्रीज होने लगता है. फिर यहाँ तक कैपेसिटर डिस्चार्ज होता है, ये वोल्टेज इंक्रीज होता है, यहाँ तक होता है, ये होता है. सो यू गेट अ बेटर डीसी एट द एंड. तो ये जो पॉइंट बी है, यही तक कैपेसिटर डिस्चार्ज होता है. सो आउटपुट कैसे मिलता है? The output is like it is more DC than before. So these are the half cycles. So the voltage is, that means it rises here, then it falls like this, again rises, falls like this, falls like this, again rises, falls like this, and you get this type of voltage. So this is V output respect to time. So we'll write the working of this filter circuit. So during the positive half cycle, during positive half cycle, capacitor charges to peak value Vp as the voltage, as the input voltage begins to decrease, the capacitor discharges through the load and voltage across it starts to decrease. And voltage across it starts to decrease. but voltage decreases only slightly because again the input voltage increases. Voltage decreases only slightly because next voltage peak of input recharges it. So this is the working of the filter circuit. The process is repeated again and again, and ripple of the input is removed. The process repeats again and again, the ripple in output is removed effectively. So this is the output at the end. It's almost DC. When a power supply is connected to a load, it is noticed that there is a drop in output voltage. Power supply whose output changes when the load is connected across it is called unregulated voltage supply. तो ये तो हमने उसको DC तो कर दिया, लेकिन और एक उसमें फैक्टर है, जब हम उसको लोड लगाते हैं और जब उस लोड में से करंट फ्लो होना शुरू होता है तो आउटपुट वोल्टेज ड्रॉप्स, and such a voltage supply, such a power supply is called unregulated power supply. The output of the power supply should remain steady even after connecting the load. और ऐसा जो होता है that is called regulated supply. तो ये फिल्टर होने के बाद भी it is still an unregulated voltage supply and we want to make it regulated power supply. So first let us write what is an unregulated power supply, and then we will see how a voltage regulator can solve the problem. Unregulated power supply. तो AC से DC करने में पहले तो रिपल फैक्टर था, अभी अनरेगुलेटेड पावर सप्लाई. A power supply whose output changes, a power supply whose output changes when a load is connected across it is called unregulated power supply. We don't want unregulated power supply, we want regulated power supply. So when the output of the power supply remains steady even after the load is connected, it's called regulated power supply. So we need a voltage regulator in addition to the filter circuit. तो फिल्टर सर्किट के बाद हमें एक वोल्टेज रेगुलेटर की भी ज़रूरत है. वी वांट द आउटपुट टू बी रेगुलेटेड, सो वी वांट रेगुलेटेड पावर सप्लाई. एंड फॉर अ रेगुलेटेड पावर सप्लाई, it is a power supply whose output remains steady. A power supply whose output remains steady even after a load is connected. It's called a regulated power supply. And we want a regulated power supply. So we use a Zener diode for this. So let us understand how we can have a regulated power supply. So for this we use a special purpose junction diodes. Special purpose junction diodes are PN diode with specific changes in their structure, so that they can be used for special purposes. And examples of such diodes are Zener diode, photodiode, solar cell, and LED, that is light emitting diode. So first we will see Zener diode. A Zener diode works on a principle of junction breakdown. Other diodes mentioned above make use of photosensitivity, a very important useful property of semiconductor. What is junction breakdown? In 11th standard we have studied that when reverse bias voltage of an ordinary junction diode is increased beyond a critical voltage, reverse current increases sharply to a high value. So for that we have to look for the VI characteristics of PN junction diode. So first let us see what are VI characteristics of PN junction diode, and then VI characteristic of Zener diode वो भी देखेंगे. These are the VI characteristics of a PN junction diode. तो कैसे होता है देखो ये इसमें कि इनिशियली व्हेन द डायोड इज फॉरवर्ड बायस, व्हेन पोटेंशियल बैरियर इज प्रेजेंट, मीन्स फॉर 0.3 वोल्ट फॉर द जर्मेनियम डायोड एंड 0.7 वोल्ट फॉर सिलिकॉन डायोड, very small amount of current flows here, but after that the circuit acts as a closed switch. You can see that the resistance become almost zero after a certain point, forward voltage. अगर वो डायोड हमने रिवर्स बायस में कनेक्ट किया तो फॉर अ लॉन्ग टाइम, यानी कि फॉर लॉन्ग रेंज ऑफ नेगेटिव वोल्टेज, डायोड एक्ट्स एज एन ओपन सर्किट. You can copy this. What I was telling कि this is the ये जो region है that is closed switch, that means resistance is very low, and this region is open switch. That means resistance is very high, almost infinity. But if you increase the reverse bias voltage beyond a certain limit, that is called the breakdown voltage, then the diode starts conducting in the reverse bias state. तो वो डायोड रिवर्स बायस स्टेट में भी कंडक्ट करने लगता है और इस सिचुएशन को बोलते हैं ब्रेकडाउन वोल्टेज. तो जेनर डायोड जो है इट इज स्पेशली मेड टू वर्क इन ब्रेकडाउन वोल्टेज. सो VI कैरेक्टरिस्टिक ऑफ Zener diode, they will be similar, but Zener diode is specially made to work in this region. तो Zener diode इसमें स्पेशली ब्रेकडाउन रीजन में काम करने के लिए ही बना होता है. So this is Zener breakdown region, and after that you can see that you get a constant Zener voltage even if the current is changed. So we use the Zener diode in this breakdown region. Diode is damaged means अगर simple PN junction diode है that will be damaged due to heating, but Zener diode is made to work in this region. Electrical breakdown of any material, metal, semiconductor, insulator can be due to avalanche breakdown and Zener breakdown. So what is a Zener breakdown? When the reverse voltage across PN junction diode is increased, electric field across the junction also increases. This results in a force of attraction between negatively charged electrons at the junction. Covalent bonds which hold the semiconductor together are broken due to the force, electrostatic force, and electrons are removed from the bonds. These free electrons are then available for electrical conduction and result in large current. When applied voltage is increased, the electric field across the junction is also increased and more electrons are removed from their covalent bonds. Thus a net current develops which increases rapidly with increase in applied voltage. Zener breakdown occurs in diodes which are heavily doped. Depletion layer is narrow in such diodes. Zener breakdown does not result into the damage of the diode. So we'll write something about Zener breakdown and then we will see the voltage regulator circuit using this. What is a Zener breakdown? One is Zener breakdown, other is avalanche breakdown. Zener breakdown जब होता है, at that time the diode is not affected or diode is not burnt. So Zener diodes are heavily doped. They are PN junction diode, but heavily doped. We'll write Zener diodes are heavily doped PN junction diode. Then what happens to them? When the reverse voltage across the PN junction diode is increased, when reverse voltage across Zener diode is increased, फिर क्या होता है? Force of attraction on negatively charged electrons increases at the junction. Force of attraction on electrons near the junction increases. When electrostatic force overcomes the force of covalent bond, when electrostatic force overcomes force of covalent bonds, electrons are removed from the bonds. Electrons are removed from the bonds these free electrons are available for electrical conduction. These free electrons are available for electric conduction and reverse current start increasing, and reverse current starts increasing. That is the breakdown region. Zener breakdown occurs in diode which are heavily doped. Depletion region is narrow in Zener diode. So how do we represent a Zener diode? Zener diode represent कैसे किया जाता है? सिंबल क्या है Zener diode का? Symbol of Zener diode is like this. So you have a letter Z like this. And then the normal diode sign is there. So this is a symbol of a Zener diode. And how the VI characteristics of Zener diode are there? They are similar to that of the PN junction diode. Only thing is that it can safely work in the breakdown region. So the forward bias characteristics are like this, just as any other diode, and reverse characteristics are like this. They are the voltage. This is forward voltage, this is reverse voltage minus VR we can say, and this is forward current IF and this is reverse current IR. So these are the VI characteristic of Zener diode. So as seen, a Zener diode behaves like a normal diode when forward bias. When reverse bias, it shows a breakdown. The current suddenly increases if the voltage is increased beyond Zener voltage. It is interesting to note that it remains constant for increasing current. So VI characteristics of Zener diode, if you want to write VI characteristics, so we can write that in a forward bias condition, Zener diode behaves as a normal PN junction diode. In forward bias, Zener diode behaves as a normal PN diode, but in reversed bias it shows a breakdown. In reversed bias it shows a breakdown. The current suddenly increases if the voltage goes beyond Zener voltage. So for VR magnitude wise is greater than Zener voltage, it is reverse voltage. When it is greater than Zener voltage, current suddenly increases but voltage remains constant for increasing current. That is special thing. Voltage remains at Vz, voltage remains constant at Vz for increasing current, and it's this feature is very useful in making it a voltage regulator. Once a Zener breakdown occurs, voltage remains constant for increasing current. This property of the Zener diode is used in a voltage regulator when Zener voltage Vz depends on amount of doping. For heavily doped diode, depletion layer is thin and breakdown occurs at lower reverse voltage, whereas a lightly doped diode has a higher breakdown voltage. So doping is how much impurity you have put into that. So for lightly doped diode, breakdown voltage is higher for a heavily doped diode. Breakdown voltage is low. So breakdown voltage is the constant voltage that is held at the output even if you change the current. So how is this means the circuit of voltage regulator? We will draw the voltage regulator circuit using a Zener diode. तो एग्जाम में ये ऐसे सर्किट डायग्राम पूछेंगे, जैसे कि हाफ वेव रेक्टिफायर का सर्किट निकालो, फुल वेव रेक्टिफायर का सर्किट निकालो, फिल्टर का निकालो, वोल्टेज रेगुलेटर का निकालो, उसका वर्किंग एक्सप्लेन करो. इस टाइप के क्वेश्चन आएंगे. सो वी हैव द अनरेगुलेटेड वोल्टेज. ये फिल्टर का आउटपुट है. इट इज रेक्टिफाइड एंड filtered, but it is unregulated. That means the output voltage changes as the load changes. There is a small resistance over here, CRS, then a small milliampere is connected. Then we have the voltage regulator circuit. In that we have a milliampere and then we have a zener in the circuit like this, and then again we have a milliammeter, and then we have a load resistance RL over there. So this is the circuit of voltage regulator. A Zener diode with breakdown voltage Vz is connected in reverse bias to the input voltage. A Zener diode with breakdown voltage Vz is connected in reverse bias across filtered output. If the input voltage increases, then the current through Rs increases. The total current flowing here is I. Zener current flowing is Iz and load current flowing is IL. So if the input voltage increases, current through Rs and Zener will also increase. This results in increase in voltage across the resistance Rs, but the voltage across Zener does not change. Series resistance Rs absorbs the output voltage fluctuations, maintains a constant voltage across load. This is because Zener voltage remains constant even though the current through Zener diode changes in the breakdown region. So if the input voltage increases, current through Rs increases, this also increases the current through Zener. This also increases current through Zener diode. But the voltage across Zener diode is kept constant at Vz. यानी जो भी ज्यादा का सारा करंट है वो जेनर से फ्लो होगा like this. Zener will absorb the excess current and the current through the load will always be kept constant. So if we write the equation of all this, voltage across Rs, that is Vs, that Vs is equal to Iz minimum into Rs. Input voltage Vin is Vs plus Vz. So Vin low is Vs plus Vz, that is equal to Iz mean Rs plus Vz. Similarly, voltage across Rs when current is maximum V in high is equal to Vs upon Vz equal to Iz max into Rs plus Vz. The maximum power rating of Zener diode is given by Pz equal to Iz max into Vz. So while designing a Zener regulator, value of series resistance is so chosen as per the specification of Zener diode. If the input voltage decreases, the current through Rs and the current through Zener diode also decreases, therefore Vs also decreases, but Vz always remains constant. So at the output you always get a constant voltage, and this is how the Zener diode works as a voltage regulator. 2 मिनिटात संपवूया आणि थांबूया. If input voltage decreases, Vs is decreased, thus decreasing Iz, that is current through Zener, but voltage across Zener Vz remains constant. So this is how the voltage regulator works. Applications of Zener diode. Zener diode is used when a constant voltage is required. It has number of applications such as voltage regulator, fixed reference voltage provider in transistor biasing circuit, peak clipper or the limiter in wave shaping circuit, or protector against meter damage from accidental fluctuations. So this is about Zener diode. We'll stop here today.